Welcome back for part 2 of repairing this Harley Davidson cylinder head. If you missed part 1, check the description below for a link to that video and get you caught up to where we're at. But now we're going to get this thing fixtured into a Bridgeport mill and wrap up this repair.
What was that?
Alright, well, I took a sander and shaped that just by eye. It's pretty darn close. When it's on the bike, you won't be able to see it anyway. See a little bit of undercut around the edge of that weld. That'll be perfectly fine. But it's shaped up pretty good. So let's get this over into the machine shop and figure out where to put the hole. I had the customer bring the exhaust flange, that way we can locate this hole. So what I'm going to do is I'm going to bolt it on with the one known good hole. And then just by looking through here, I can line up the bore with the bore on this flange. I'm going to take a transfer punch and locate a center punch mark. Okay, I got a good mark. Get this out of my way, and then I'll make that impression a little deeper. All right, we got that located. Let's get the mill set up. Alright, so I've got my own machine shop in-house here, and I've got a bunch of mills, but I have one in particular. This one right here is the one that I never have this head trammed to the table. This is the one that we move the head all around to all the crazy angles for doing unique operations. We've got some other mills here. I always keep this manual mill 100% trimmed, flawlessly perfect. We check it every once in a while, make sure nothing moved. But that vise, that head, everything's set up for doing really nice precision manual work. And we've also got the CNC Bridgeport, and we got some bigger mills and CNC mills and lots of lathes and shapers and stuff like that. But we're gonna focus on this guy. So we need to get an angle plate on this table. Get this 90-degree head off of here. Let's get this set up and ready to drill that hole at a unique angle. I'm trying to have this as high as possible. I want to set this angle to something simple like 45. So it'll be a lot easier to dial this head in if we have an idea of where it's at. Let's put it at 60. And that's real close to 60. I'm going to snug it, then we'll bump it around. Alright, so now for the fun part. Gotta get this head at the right angle. I already see a potential problem. I think we're gonna have to slide this down. Close enough. So I've got this surface set to 60 degrees, which means I have this set to 30 degrees. Since we're coming off of 90, this is 60 degrees to the table. When this is at 0, it's technically 90 degrees to the part. So 90 degrees minus 60 is 30. So I put an angle finder on the quill. We've got this set to 30. Now we need to figure out the angle to tip it back to come in at the right angle. So we'll set that next. Well, to figure out the second angle, we're going to take a piece of dowel rod that fits the existing hole very snug. Clicks in there nice and sturdy. We can use this rod to tram in this quill. We can also use it to verify both angles by using a collet or a drill chuck and making sure that it slides on this exactly right. Then all we have to do is move the table up X, Y, Z to line up with our center punch mark. So we'll use this to set our second angle. We'll verify our first angle as well. And then we'll get lined up over our center punch mark. Bring the table up. You see our two different angles here, so we're going to tilt this back, move them right next to each other, and get them lined up. This table over again. Okay, so you can see we are close, but we need to go in a little more. Need two hands for that. Okay, I think that is about correct. They are perfectly parallel. We're not going to measure this out to the 100th thou or anything. We've got an equal amount of light showing. That is good enough. Alright, so we have verified the one angle off of the back side of the quill. Could have used it off the front side as well to get that same angle. Now we're going to verify our first angle where we use the digital angle finder on here and set this to 60 and then set this to 30. All we have to do is come off of either the top or the bottom and we can verify that. We can't get to the top because this table won't go high enough to get that up over top, but we'll come down and come off the bottom. So we're checking it at 90 degrees. So we did one side, good. Would be the same as this side. We're going to come down 90 and verify that second angle. Once we're good, we'll throw the drill chuck in here. We'll pilot that, get it drilled to the right size for the tap. Alright, so we're going to come down until the dowel rod is underneath the quill. By a good amount. I don't want to bump into it and screw anything up. We'll come out, get under the center of it. That's about the middle there. Now I'll come up slow till I'm nice and close. And I'll get you in here for the shot. Cranking up slow. And it is just a hair off. It's a little closer on this side than this side, so that head needs to be bumped down. And I'm just going to give that a tweak, make that perfect, and we're good. I gave that a tweak. I'm very happy with that now. Let's get this set up with the drill. Alright, first thing I'm going to do is I'm going to just peck this off with a 1/8 inch drill bit. Because my center point mark is not very deep. Getting this lined up is a little tricky. We've got our center punch mark in there. Let's see if I can even get a shot of this for you. It's really kind of hidden. So let's see, we need to come back. See the 1/8 inch drill bit trying to center in that center punch mark. It's hitting the edge and actually bending the bit a bit. I think we've got it hitting that center punch mark perfectly in the middle. We should be good. Alright, I think we got everything set up, ready to go. Got the mill in low speed. Let's fire her up. And I'm going to set this at like 200. Don't mind all that noise. This thing's got a belt getting ready to come apart in the head. We gotta get that replaced soon. Gonna come down and give this a little peck. Clearing the chips out. All right, so we've got a real nice center hole, drilled about 1 inch deep. Let's get the correct size drill bit out for this tap. We're doing a 5/16 18 thread, which requires a drill bit letter F. Before we did anything, I made this little depth gauge off of the existing hole, so I knew how deep it needed to be. I took some electrical tape and I put a strap of tape at the depth that we want to stop drilling this hole. So let's plunge this into there and keep on moving. We're going to go nice and slow. We don't want to have anything crazy happen this deep into the game. Keep clearing those chips out. They might be touching off. And the what was remaining of that factory hole. Okay, we are at our final depth, right to that tape line. Let's get the chips blown out of the hole. Look down in there with a mirror, and that looks beautiful. Get the drill bit out of here, and we are not going to power tap this. We are going to use the mill to keep us centered and straight. So Grade Ledge CNC sells this really nice spring-loaded tap centering tool. I'm going to put this in a 1/2 inch collet. Now, the mill's not going to be running when we do this. We're just using the quill to keep the tap running perfectly straight. We've got our 5/16 18 tap. Confirm that. Yep, we are correct there. And what you do is you bring your quill down, and on the back of any tap driver there should be a centering hole. Now we will compress that spring load centering tool and lock our quill from extracting back out. That keeps us in a perfectly straight line. So now we can drive this tap handle by hand, and it ensures we are running in a straight line with our hole. As we get deeper and deeper, that spring-loaded center is going to come out. If you need to, at a certain point, stop, bring the quill out further, recompress that spring, relock your quill, and go to your final depth. And you might need to even do that a couple times. All right, so this centering, I can feel there's not a lot of spring left on that. Unlock the quill, bring that back down, relock it. And that feels like bottom. Nope. Just a little bit of a hard spot. It went by. That is definitely bottom there. I'll take note of how many, 1, 2, 3, 4. I can take this out and compare that. See how deep I am compared to my gauge. I'll know if I'm at the bottom of the hole. Let's get this quill out of here and take this tap all the way out. Let's blow the chips. Checking the tap with my gauge. I should have 3 teeth showing. I had 4. That's close enough because I know for a fact that factory bolt did not go to the bottom. Look in there with the mirror. And that looks perfect. So I'm just going to chamfer that edge a little bit. I'll do it with a hand tool. So I can't fit my chamfering tool in the mill and fit it past the fixture block. So we'll take the head out of here, take it to the bench, chamfer that, make sure the bolts start easily, make sure that that flange bolts up, both bolts, everything's in the right spot. We should be about ready to go. Alright, let's chamfer this little hand chamfering tool. Just break that edge a little bit. Alright, let's see how we did here. Put it in the original hole first. Look at that. It is perfectly center of the hole. This ring is lined up all the way around. The head of the bolt is parallel to the flange, so you know they're at the correct angle. It's not like cocked or tipped or anything. I'm happy with that. When this bore is lined up, the flange, that bolt is dead center of that hole. Everything lines up just how it should. Bolts together very easily. You don't have to try to force the bolt in. It is dead center of that flange hole. And they won't have any problems putting this bike back together. So the corner is welded up, reshaped, hole drilled and tapped in the right location. That's a pretty nice, easy repair. It took a couple hours, but I don't know if we could have done it any faster other than just hand drilling it and avoiding using some precision, but that's how they got in trouble in the first place. That goes in on a little bit of a unique angle. It's got to be right. Trying to find that with the hand drills would never be real accurate. Well, I hope you enjoyed watching this video, maybe learned a few things, or at least found it a little bit entertaining. So hopefully you never get into this exact situation, but if you do find yourself with a broken bolt in an odd location, my rule number one is don't ever in a million years try to drill out a broken bolt. Don't ever try to drill it and use an easy out or anything like that. Never ever. Take it to a professional if you don't have a welder, but the key is use a welder. You can always get that bolt out every single time. It has never failed me in 20 years. I have never drilled out a broken bolt. All it does is lead to more problems. I can get it out in a couple of minutes with a welder. So if you run into a situation, just take it to a professional. I probably could have gotten this bolt out in less than 5 minutes on the bike with the TIG welder and saved this customer a ton of time, a ton of money. They wouldn't have had to take their motor apart. But either way, we got it fixed up. They'll get back on the road. So again, if you like this, give it a thumbs up, subscribe, follow along. We'll have lots more videos coming up. Appreciate it. See you guys.